Here we are at section 2.8. Sections 2.5, 6, and 7 are straightforward. Read the textbook. It's material from your first year of physics. So section 2.8 also starts our very first video problems. So video problems are just simple examples of calculations that are in that particular section. So in this case, we're talking about video problems 1 through 3. And they're all on density. Okay? So density is a physical property, which means that I can use density to distinguish types of matter. For instance, if you have a pure gold necklace, which you're not going to, right? You got like 24 karat gold, 14 karat gold, and if you have a, let's say, pure gold necklace, and we determine the density of that necklace, if it does not match the density of gold, then it is not pure gold. Okay, so gold can be used to distinguish matter, one property. Okay, you usually want several properties that you can verify. Density is one of them. Density is really a ratio. It's a ratio of the mass of the substance, which we learned is measured in grams, versus the volume of the substance, or how much space that takes up, which is measured either in milliliters or cubic centimeters. Okay, it just depends on if you're measuring in milliliters or centimeters. So density is what determines whether objects will float in another object or not. It has nothing to do with mass. So oftentimes I'll ask, hey, why does this float? And someone will say, well, it's lighter than the material that it's in. No, it's not lighter. So for instance, let's say I take 5 grams of ice. So I've got 5 grams of ice, and I put that into 5 grams of water. Well, guess what? That ice is going to float in the water. Same mass. One is not heavier or lighter than the other, but yet the ice still floats. The ice floats because it is less dense than water. That's why the ice floats, and that's the proper terminology. Less dense, or denser, actually. So the water is denser than ice. So here's just a little example. We've got cork and ice both floating in the water because they are less dense. So here's the density of cork, 0.26. Here's the density of ice, 0.92. And those are both less dense than this water, which is 1.00. The aluminum, chunk of aluminum, chunk of lead, both sink because they are more dense, or denser is the proper term. They are denser than water. So what does it mean to be denser? Well, usually what we're talking about when we say that it's denser, it means that there are more particles packed into that space. So take a look, let's say lead. There are 11.3 grams in 1 milliliter of lead. Now compare that to cork. There are 0.26 grams in 1 milliliter. So we can say that the lead is more compact. There's more stuff packed into the same amount of space for lead than there is in cork. Okay, so here's just the density of common substances, which is on our pink sheet that we have, our equation sheet. You don't have to memorize any of these things. The only one that you really need to know off the top of your head is the density of water. So the density of water, we usually say it's 1 gram per milliliter. Now, you can always go by that 1 milliliter of water weighs 1 gram, and 1 gram of water takes up 1 milliliter of space, unless you measure the temperature of the water. So if you measure the temperature of the water and you have a water density table, then from the temperature you can figure out the density of the water. And we have a couple labs where we do that because we want to know, we want to be more accurate than just this rounded off value. Because as you change the temperature, you change the density. And later on in subsequent chapters we'll talk about why. But for now, just know that the density of water is 1, but it does change with the temperature. So again, take a look at your video problems for some example calculations. And the video problems not only show you the example calculations, they also show you the proper way to show your work, which is really important. You always have to show 100% of your work. So how can we measure density? Well, to measure density, we actually have to measure mass and volume. So we don't we don't exactly measure density. What we measure are mass and volume, and then we calculate density. So density is a calculation, not really a measurement. So we're going to measure the mass and volume. Now the mass is pretty easy. For the mass, you just throw it onto an electronic balance. The volume, it depends on what you have. If you have a regularly shaped object, in other words, let's say you have a cube, right? So a cube is a regularly shaped object. Basically, if there's a name for that object, it's regularly shaped, right? So there's a cube, there's a sphere, there's a rod, right? So anything that's a regularly shaped object, then you can calculate the volume. If it's an irregularly shaped object, you have to use what's called volume displacement. And so here's an example of volume displacement right here. So here is a graduated cylinder, has a volume of 35.5 milliliters, and that's without this object thrown in there. Now, once we throw the object in there, the volume goes up. The volume went up to, in this case, 45. So the difference in volume is the volume of this object. This is Archimedes came up with this idea. Just do a quick Google search on Archimedes and it'll probably be the first topic that comes up. So again, the volume displacement, how much water was moved, is our volume of the object. Now again, we have a density lab and you'll figure out volume both ways. So sometimes you'll measure it, sometimes you'll do volume displacement, sometimes you'll do both to the same object. So once you have your mass, your density, once you have your mass, once you have your volume, you just divide those two, and that's how you get your density. So there you go. Section 2.8.